Hello everyone, this is Sanjay Krishna from Worktez. I'm here to give a brief introduction on the prototype we have built from Worktez into the Metaverse. So this is the prototype we have built for it, and the character can move around in it, and we are planning to add more elements to this. And as the first basic stuff, we have added the floors, we have added the walls, a static element, and the character will be staying inside this fizzle. So let's quickly look into the code then. So this project is built in Angular, so it has a basic Angular file structure as app inside that body, and we have three other components, that is cube, scene, and pattern. I'll explain them quickly. So cube component is the component which we started first to build. It's just a basic cube, and then we added an animated character, that is the Spartan, and the thing which we saw the demo was the scene component. So let's concentrate only on that now. So the scene component.html has nothing but a canvas, and it's just simple style, colors, height, and width. That's it. And all the things happen here in the TypeScript. So I have imported these three things. That is from the Angular code. That is common thing. And I have imported the three. And I have imported FBX loaded to load the characters. And these are the things I have declared in the root level. There's the camera, mixers, walls, whichever we use here. And these are the variables I'm using for tracking the keyboard events. As this is TypeScript, we cannot use the basic JavaScript keyboard events. So and then we are using FBX loader, renderer, scene component, and these things. And we'll come back to this keyword event handling a little bit later. And how it works is, first after view init, the create scene method triggers and the start rendering loop triggers. So let's go to create scene method now. So the virtual worlds also work in the same way how the world works. Okay. So in the world we need eyes to see things, we need light to see things, see an object. In the same way, in the virtual world we need a camera, we need an object, we need a light to see the things. Correct. So in the same way, we create a scene here, and we put a background for the scene, and we put like fog, which applies as a blur, which is more than 3000 units far away, which is not necessary for us. And we have added a light here. There are a lot of types of lights. So if you see here, there are ambient light pro. These are the types of light which 3JS provides. You can go through the documentation if you have any doubts. And we are setting the position of the light in the 3D space. I'll explain about setting the position in a minute. And we are adding this to the scene. So every object you create should be added to the scene, either it be camera, light, an object, everything should be added to the scene so that you can view it in the space. And we are using FBX loader to load the FBX format. So there are a lot of forms of 3D objects like FBX, GLTF, etc., which can be which can be created with the help of Blender, which is an open source tool. Either it can. There are a lot of free resources available in the internet. You can use those. And this is the character we have imported, and I have scaled it down to half of the size as it was too big. And I have a mixer here, which is an animation mixer, which gets all the animations from from that FBX file, and it stores here. And we are assigning the object to cube, and we are adding that to cube variable, and we are adding that to the scene. In the same way, we saw T here, so I'm adding that in the same way. But here we do not have any animation, so I'm just assigning it and setting the position for it, and that's it. And you would have seen the boundary walls here, so that is how it is added. So we create a mesh with the box geometry. There are a lot of types of geometry too here. You can see here there are box geometry, so like these. So these are useful for creating various shapes, as the way you can go through the documentation for creating those. And we have a material for it. We create a geometry with that mesh, and then we apply material to that mesh. That's it. Even in this, there are a lot of types of materials. You can go through that too. So if you see here, there are line basic material. So there are slight differences between those materials. You can learn that with that documentation, and we are setting the position for it. And why this compute bounding box is nothing but we are computing the edges of the box so that we can calculate the edges of it so the character does not go out, and we are adding that to the scene in the same way. So you would have seen this floor design, so this is nothing but a grid. So we use grid helper for it. There are a lot of types of helpers in the same way, and we are adding it. And this is the important thing, we are adding initializing the camera here. And so this is a perspective camera. So FOV is nothing but the field of view. So if the field of view is like small, then it will be your the view will be like small. You will be seeing a small portion of the 3D space. If the FOV is like great, then you can see a wider space in the 3D. And aspect ratio, it's the thing which you have come across, like 16 is to 9, those that is the aspect ratio. And near and far, it is similar to the far clipping and near clipping. So if an object is far away beyond 4000 units, then it will not be rendered. It is to like reduce the load on the loader. So it's not useful if we load the objects that are far away than 4000 units, which is not going to be visible. So that's so we use that for it, and we are setting the initial position as 000, and then we are loading the Worktez image as a texture here. So we create a plane and we apply that texture here, so as the image. So you can go through this, and then the second method that was triggered here was start rendering loop. So in this, we use WebGL renderer to render the 3D images, and we are setting the size and pixel ratio for it. And then the request animation frame render, what happens here is this makes the function called recursively. So this calls the update method. Let's go into the update method. So here we get all these set all these values, like we get the seconds here, and we set these things like how much it should move for a second, like it moves 200 pixels per second, and pi by 4 radians, that is 45 degrees per second it turns. So the turn angle will be 45 degrees per second. And we have this condition. So you would have I would have shown you this compute bounding box. So we use this here to calculate the edges of it. So let's say if the cube's z position is like less than or equal to this bounding box minimum. So how it works is that let's say this is the z and this is 000, and here is the 1000, and if we see here, this will be minus 1000. So that is how it works. And we like reduce the thing by one so that it stays inside the bounding box. So if the condition matches, that is if the, so I've added the conditions here, the all the conditions. So if the object is inside this space, then we will be like moving it. So how this works is that we are using w pressed variable as I shown here. So how that works, let's see that. So we have two events called as key down and key up. So on the key down event, we set this w pressed as true, and when the key goes up, it sets as false, and animation stops here. I'll show you here. So when this variable is true, then we play the animation and we move the distance. And in the same way, when the yes is done, we move it in a reverse, and Q is pressed, we move it left, and when E is pressed, we move it to the right. And when A is pressed, we turn it to the left, and D is pressed, we turn it to the right with 45 degrees per second. And we have this. This is an important part where like we have to set the position of the camera with which it is going to be viewed. So to calculate this in a 3D space, it goes complex, and it like needs a lot of trial and error method. But the simplest way we found is that there is a thing called as 3JS editor. And if you need a field of, if you need a like view angle like this, let's say you need to view the view it in this way, like the axis is going to be first, and you need a like a little bit top, then you can go here like this. If you need a view similar to this, then you can click on this camera and it will give you this positions. You can use these positions. So let's say if you need a top view, let's say you need a top view, and you can see here both the things are 0 and this has some value. So obviously you can copy these values and you can use it here. So in the same way, we would have seen the position dot set. So you can like for whatever you want, like a point light. So you can move the light anywhere in the space, and you can copy that position here. The position changes, and you can do that. So that's the easiest way to apply the positions for it. And this update matrix and update projection matrix needs to be called so that acts as a refresh thing. That's it. And that's it about the code. And we have the other components like cube, which has only the cube, and we have done that. And these are the ways we travel. And we added the first thing which we added was the gltf thing, and we moved to fbx loader, and this will be improved. And here is a repository. You can always look into this for future updates. Thank you.